3.7a optimization problems, and we need to start reading some guidelines for it. And who's going to be our reader? Danielle, go for it.
Guidelines for solving applied minimum and maximum problems. 1. Identify all given quantities and all quantities to be determined. If possible, make a sketch. Do I read the rest?
Yeah.
2. Write a primary equation for the quantity that is to be maximized or minimized. A review of several useful formulas from geometry is presented inside the back cover.
All right, so we need a primary equation. That is what's being asked to be minimized or maximized. All right, that will be this one that we finally take a derivative of. All right, keep going.
Reduce the primary equation to one having a single independent variable. This may involve the use of secondary equations relating the independent variables of the primary equation.
All right, fantastic. So it's going to give us a secondary equation to get. But what we're going to do is we're going to solve for a variable and substitute it into the primary equation to now have one variable. All right, that's what we're going. All right, keep going.
Determine the feasible domain of the primary equation. That is, determine the values for which the stated problem makes sense.
All right, we might get extraneous sometime. Keep going.
Determine the desired maximum or minimum value by the calculus techniques discussed in sections 3.1 through 3.4.
How do we get a max? How do we get a max? F prime changes from positive to negative. How do we get a min? F prime changes from negative to positive. All right, do it. Here we go. So this first one, we're going to find the product to be 185, and the sum is a minimum. So we're going to find two positive numbers that satisfy these given requirements. The product is 185, and the sum is a minimum. Well, let's break it down. How do we get a product? We multiply. All right. So two things being multiplied is 185. So what would that equation be? A times B. I'm going to use X and Y. So X and Y equals what? 185. All right. The product of those two is. Whenever you see is, that's an equal sign. All right. And the sum is a minimum. Well, what is the sum? S plus Y. So I'm going to say S, the sum is equal to X plus Y. Now, which one is my primary and which one is my secondary? Which one is being asked to be maxed or minned? The sum. So eventually, I'm going to take a derivative of X plus Y. Are you following me? However, how many variables do I have going on right now? I have two. Yeah, S is kind of a variable, but really I have X and a Y. All right? I need to get that in a singular variable. So I need to solve for X or Y in this X times Y equals 185. Now, does it really matter on this one? No. Which one do you want to solve for? It doesn't matter. Y. So Y is equal to what? 185 over X. So now I'm going to take this and I'm going to substitute it in right there. Okay, so now my sum equation is equal to X plus 185 over X. See how we did that? All right. Now I'm going to take a derivative of that. So I'm going to take it with respect to what? What are my variables in? X. So my derivative, I'm going to say ds over dx because that is who I'm respecting. Well, what's the derivative of X?
dx dt.
Just one. It's dx dx, right? So it's just one. And then, what's the derivative of 185 over X? Let's see if we're good at these now. Negative 185 over X squared. And again, if you have to go off to the side still, you shouldn't by the time we've been doing these, but this is 185x to the negative first, right? So negative 1 comes down, subtract it, we get negative 2. But we should be really good at these if we've been doing our homework. What am I going to do after I take a derivative? Set it equals 0. I'm going to set it equals 0. So then I end up getting 1 minus 185 is equal to x squared. So 1 is equal to 185 over x squared, right? Well, how do I start solving for x squared? Multiply by x squared, and then I get x squared is equal to 185. And then what do? we square root both sides. So I get x is equal to plus or minus, really, square root 185. Now, is it going to be the negative one of it? No, that's the extraneous solution. So we end up getting x is equal to square root 185. Now, what we technically should do is we should actually substitute in right there. I should try to figure out a sign chart from it. All right, so let's just do it real quick. If I got 0 to square root 185, and then square root 185 to infinity, basically. I need to figure out if my derivative goes from negative to positive, right? That's really what I'm looking for. So if I substitute in a number from 0 to 185, or square root 185, like, I don't know, 1 should work there. So if I substitute in 1, do I get a positive or a negative number? I get a negative. So ds dx is less than 0. And if I put in something bigger than square root 185, I should get a what? I should get a positive. So ds dx is greater than 0, which means it created a what? A minimum. It created a minimum. So that's what was being asked, so we did it right. So that's good. So one of my x values, one of my numbers, x is equal to square root 185. Now I need the other one. So how do I get the other one? Substitute back in. All right. It doesn't really matter which one you substitute back in. This one's already solved for y, so it'd be 185 over square root 185, which again is just what? Square root of 185. All right. So my two numbers are actually the same in this one. All right. Pretty cool. All right, let's keep going. All right, we got a hard one now. Let's do it. I need a reader. Thank you so much, Lucy, for volunteering.
A manufacturer wants to design an open box on a square base with surface area of 108 square inches. Thus shows surface area 3.53. What dimensions will produce a box with maximum volume?
All right, so I'm going to have two equations. So let's do it. So it tells me the surface area of an open square box is 108. All right. So how do I get a surface area of an open square box? What would the bottom be? If we need to draw a box. All right. This would be x, this would be x, and this would be my height, right? If I do my surface area of it, how much is my bottom? X squared, right? It's a square box, so I have x squared. All right, so I have x squared, then plus, what would be all of my sides? One of my sides would be x times what? H, right? And so, how many sides do I have? 4. So what would the surface area of the sides be? 4 times xh, right? Because I have xh, xh, so forth, right? And that's equal to what? 108. All right, that's equal to 108. Now, the question being asked, what dimensions will produce a box with a maximum volume? Well, how do we get to volume? How do we do volume of this box? How do you do volume of a cube or volume of a rectangular prism? Length times width times height. So what are my lengths and widths? X and h. So it would be 8x squared times h. Now, eventually, I'm going to take a derivative of that volume equation, right? Okay, I'm going to get to dv something. However, I have two variables going on right now. I don't want that. So what should I do in my secondary equation of this x squared plus 4xh equals 108 thing? Solve for what? H. There we go. So let's solve for h. So what do? We first... I would not. I would subtract what? X squared. All right, so now we have 108 minus x squared, and then what? Divide by 4x. So that's what h is. See how we did that? All right. So now we're going to take this, that's what h is, I'm going to substitute it in there. So now I end up having volume is equal to x squared times 108 minus x squared over 4x. All right. Now, we could take a derivative like that. However, I don't really want to. Are you following me? I kind of want to simplify up before I take a derivative. Yes? All right, so let's do it. So I'm going to distribute my x squared, and then I'm going to divide everything by what? 4x. All right, so I get 108 x squared divided by 4x. All right, what is 108 divided by 4? What's 100 divided by 4? 25. Good. What's 8 divided by 4? 2. Add them together. 27. We get 27. All right, so we get 27x. All right, so then x squared times x squared divided by 4x. So x squared times x squared is x to the 4th. And then I divide by an x, so now I have x cubed. So then this is minus x cubed over 4. So there's my volume equation. You can take as many steps as you want to get right there. All right. All right, so now what am I going to do with that? Take a derivative. So now I'm going to find dv dx. So what would be my derivative? 27. And then minus what? 3/4 x squirt. What am I going to do with that derivative? I'm going to set it equal to 0. All right. So we basically have 27 is equal to 3/4 x squared. So what should I do? Multiply by what? 4/3. I multiply by 4/3. So 27 divided by 3 is 9. 9 times 4 is 36. So I have 36 is equal to x squared. So what does x equal? 6. Technically, it's x is equal to plus and minus 6, but do I want the plus and minus part? No. Does it make sense to have a negative side length? No, you can't have that. That'd be extraneous. All right. So what dimensions will produce a box with a maximum volume? Now, technically, I should figure out if my derivative goes from positive to negative. All right. I should probably do that. However, I'm just going to say it works. Sounds good? All right, cool. So then, if we substitute in, what's one of my sides? 6, right? By what? 6. By what? Now I have to figure out my what? My h. So this one's already solved for h, so I'm just going to substitute it back in right there. So 108 minus 6 squared. 6 squared is? 36. 108 minus 36 is? 72. 72, good. All right, and then 4 times 6 is? 24. 72 divided by 24 is? 3. So we have 6 inches by 6 inches by 3 inches. That is the maximum volume with a surface area of 108 square inches. All right. You ever seen boxes on the shelves, like the cereal aisle and stuff? Your Ritz crackers? Oh, yeah. Do you think somebody along the lines did calculus? Yes. They did. They did. All right. They maximized their volume and they reduced the amount of cardboard that they needed to use. All right. They really did. Here we go. I need a reader. The farmer is Gandhi. So here we go. Fire's going to read about Gandhi. Gandhi.
Gandhi has 2,400 feet of fencing and wants to fence off a regular field that borders a straight river. He needs a fence. He needs no fence along the river. What are the dimensions of the field that has the largest area?
All right, fantastic. So Gandhi has cattle. All right, he has a ranch, and he needs to figure out how to build a fence. All right, so we need to figure this out. So yeah, we could figure out I don't know, guesstimate, blah blah blah. But let's use some calculus. Let's use some calculus along. So let's draw a picture. All right, I will guarantee one of these will be on your test, guaranteed. So we got a river, and then we got some fencing. So how many sides do I have for this fencing? I have three sides. And the way I think about it is I have x that goes horizontal, and I have y that will go vertical, right? Follow me? So what do we need to do? What are the dimensions with the largest area? Well, how do we find area? X times y. All right. And then what's given to me? How much fencing does Gandy have? 2,400. So 2,400 is equal to what?
2y plus x.
2y plus x. There it is. Now, I have two variables in my primary equation. Area is equal to xy. I don't want two variables. I want one variable. Now, this is where working smarter, not harder, is really coming into play. Which variable, if I have this as my secondary equation, would I solve for? Would I solve for x or would I solve for y? X. Why x, guys?
Because it's by itself.
Because it's by itself. All right. Now, if you solve for y and you do all the math correct, will you still get to Tampa? Yes. However, then you're going to deal with fractions. I don't feel like doing that. All right. So let's solve for x. So what does x equal? 2,400 minus 2y. So now what am I going to do? Take this and do what? Substitute it in right there. So now area is equal to 2,400 minus 2y and then times y. Now, you could take a derivative of that. I don't want to. Bless you. So let's distribute. So my area equation would end up being 2,400y minus 2y squared. Now, we're asked to find a largest area. So really, I'm finding a what? A maximum. I'm finding a maximum area. That's really what it's saying. So what do we need to do? Take a derivative. So what would my derivative's name be? dA what? dy, because now I'm with respect to y here. So what's my derivative of 2,400y? 2,400. And then minus... And what do I want to do with that? I want to set that equal to 0. So now I have 2,400 is equal to 4y. So what does y equal? 600. So y is equal to 600 feet. Now, what do I need to do now? Substitute that back into that one. All right. So now x would be equal to what? 1,200 feet. All right. So what are my dimensions? 600 feet by 1,200 feet. All right. That would be the dimensions that would be correct for Gandy to use. All right. Pretty good. Now, I'm going to teach you a little trick. If you have a problem that have these three sides and one side is not being used, it's going to be two squares. You see what happened? It will be two squares. All right? Because it will be 600 by 600 and 600 by 600. If you have three sides and one side is something else, it will be two squares every single time. All right? So if you actually know that little trick, you don't really need the calculus. Well, actually you do, because I'm checking other things other than your answer. All right? Pretty good? All right. All right, we will do part B of optimization tomorrow.